Okay, this is downstairs in the basement, or not the basement, the lower level. This is my thermostat for zone 2, which is the bathroom and also the room directly above me. And here's my thermostat for zone 1, which is everything out here, all of this craziness. And let's go take a look at what we've got upstairs. There's the utility entrance to the utility room over here. I haven't put the doors on yet. Baby steps, I'll get there. So here in the utility room, we've got 2 water systems. I have the hydronic heating system, and then I have the heating and water system for the barn. They're separate. So my hydronic system is not hooked up to my well. They're a separate system. I haven't filled it yet. The hydronic system will be filled with a mixture of distilled water and glycol designed specifically for hydronic systems. That way, if I ever lose power and it gets cold enough out here that would normally freeze water, my pipes, which are inside the concrete, won't freeze because, you know, if they just had water in it and dropped, they'd freeze. And when you have a frozen pipe inside concrete, things go very, very wrong. So that's why I'm going to have the antifreeze glycol in there. So let's take a quick review of the 2 systems. This is the water heater for humans. My water filter is not a filter in there yet. Water softener, because I have really hard water out here at the farm. And then after the water softener, this is the hot and cold distribution unit. Yay, okay, that's water for the barn. You really don't care about that. What you care about is the hydronics. So let's talk about that. I am using an 80-gallon standard water heater instead of a boiler. The barn is run on electricity. I'm not using gas. And eventually I'm going to put solar in here because I'm kind of a hippie. So I wanted an entirely electric system. So the water heater is electric. It was about $400 versus nearly $3,000 for an electric boiler. I'm just going to use the water heater. It'll be just fine. It's got a whole, it's 80 gallons, so it holds a lot. This room is fully insulated, so it's warm in here, so it'll be good. And I haven't insulated any of this yet because, like I said, it's not filled. So let's follow the system. Coming out of the water heater, we come over here to a pressure and temperature gauge, and it continues and feeds up. Here is my expansion tank. Because it's a sealed system, you know, heat, water, things start to expand. I need to have a place for the tank to expand. So here's my expansion tank. Sorry about that. I accidentally pressed the off button on the record. There's the expansion tank. Anyway, the water continues on. This is an air bleeder. It captures air. There's like a coil of metal and stuff in there. It bubbles out and it allows the air, any excess air trapped in the system, to vent out the top. And we come over here, pressure relief gauge. This is nothing more than a place for drained water to vent and go down to the drain. So if I have a overpressurized system more than the expansion tank can handle, the water will vent out there. Comes down to here, comes down to here. Here's my valve above my primary pump. So I have 3 pumps in the system, 1 primary for the primary circuit and then the 2 secondaries. We'll get to the secondaries in a minute, but let's follow this through. So the water comes, the hot water from the heater comes through the primary pump, down here, comes over to here. This valve is currently closed, and then it will feed here, here, and then out down here, and then that line back there, that copper line there, that copper line there, that copper line there, that copper line there, sediment filter, back up, pressure and temperature gauge, back into the water heater. So it's a circuit. It just circles constantly, blah, blah, blah. Well, not constantly. It'll only circulate when, you know, the motor's on. I'll explain that in a moment. So it's going to circulate. That is a closed system circulation. Now, what I also have are the secondary pumps. These are the pumps that get activated when a particular zone calls for heat. I showed you the two thermostats downstairs for the two separate zones. Right here, we're still in zone 2, which is the bathroom zone, and zone 1 is the one out in the garage. So my controller here, yay. When any zone calls for heat, zone 1 or zone 2, and we're unplugged right now. When zone 1 or zone 2 call for heat, the primary pump will switch on, and that'll activate this system. With a boiler, you would also have circuitry that would suddenly turn on the boiler. With a water heater, this water heater is just independent of the zone controllers. It will keep the water at the temperature that I set it at all the time because it's a freaking water heater. That's what they do. It's not that complicated. Anyway, so when a zone calls for heat, this turns on. When whatever zone it is that calls for heat, then the appropriate pump turns on. So let's talk about zone 2, which is my primary zone. What? It's weird. Why is zone 2 the primary zone? Why isn't zone 1 the primary zone? Because the people who made the frickin' controller here designed it for zone 2 to have priority. So makes no sense to me either, but that's how it is. So zone 2, when it calls for heat, what will happen is this pump will circuit on. Everything is circulating the way I told you, but then water will be drawn through here out of that primary circuit through the zone 2 pump down to here, down to here, and it feeds into my 2 lines which go down into the floor. One of them taps off over here, and I explain this tap in another video, and it goes down through the floor, comes back to here, circuits up, over, up, back right into here where we were, and it continues that circuit just like we talked about before. The same thing happens when zone 1 calls for heat. It will draw through, comes down to here, to here, into here, feeds this system. All 4 of these lines go straight out and down into the concrete, into the slab for the main barn. Comes back here, circuits up, over, connects into that same T, back into the circulation. Not really that complicated a system, but that's how it will work. Can't demonstrate it right now because I don't have any liquid in it, and I can't turn on the motors without any liquid in it because I'll burn the motors out. So when I do get ready to fill it, I'll fill here, right here. There's a valve back there. Goes in, fills the system, and it'll bleed and drain out there. And that's kind of it. Nothing super complicated about it. Basically what I've done here is I've kind of cheated in that I could have bought this pre-made. I could have bought a pre-made panel for the primary circuit and a pre-made panel for the secondary circuit, and that would have not including the controller. So I could have bought the 2 panels, and it would have cost me about $2,000 for the primary and about $1,900 for the secondary. Last time I checked the prices, so nearly $4,000 to get that done if I purchased the stuff. Instead, I bought the individual components, put the system together, taught myself how to sweat copper, and put it all together. Got about 600, maybe 700 into the system. So I saved quite a bit of money. I spent it in time. It took a lot of time, but I also have the pride of this is my system that I built, and I think it's pretty cool. So anyway, we're ready for water. So thanks for watching. Okay, the water softener is doing its initial charge. I did my initial fill test. The water came in here on the main. I had a leak on that connector there. It's since been fixed, but it made a bit of a mess. But that was the only leak. Everything else is fine. So I've got the water softener charging, or doing its recycle, so it's ready to rock. And then I'll do my initial fill on the hydronic system with this water, softened water, to do the pressure test. And once the pressure test is completed, then I'll dump it and put in the distilled water and glycol antifreeze. So the water will come out of my washer connector here. That's the cold water line on the washer. And it'll come all the way up, go to the inlet there, go through the entire system, fill it, get it pressure tested, come back out through this hose, which goes down and around and outside the barn. And the reason I've got to use hoses is because I don't have my drains hooked up to the barn yet. I'm still waiting to get that accomplished, but I got to get the heat in. So it's a weird situation. But the cover's in. Everything's good. We're completely ready. Ready to test as soon as this is done. So I'm gonna go have breakfast. Let this do its recharge thing.